Welcome to my lecture. Today we are going to discuss about center of pressure. This term is more related to the blanking operation. Let us see a simple blanking operation with an example. Here, as you can see, when the punch plunged into the sheet metal strip, the blank is removed from the strip. So whenever the punch descends into the workpiece, the particular shape, here it is a circular shape blank is uptime. Okay, so this is the useful component as far as the blanking operation is concerned. It is useful for drawing and piercing operation. The material which remains in this sheet metal strip is called as scrap. So what is center of pressure? How it is related to this blanking operation? Let us see now. In blanking operation, when the punch descends into this metal strip, shearing happens. Because of shearing, the blank is removed from the sheet metal strip. Here you can see the entire resultant force must pass through the center of the blank. So it is an imaginary point in the blank at which the resultant force due to shearing of the entire profile is supposed to act. It is otherwise called as center of gravity of the perimeter. Okay, so we have to remember that it is not the area, it is the perimeter of the blank. Why is so important? So when the punch descends into the metal strip, if the resultant force of the shearing does not pass through the center of this blank, what would happen? So the buckling load may act. Because of that, quicker wear and tear of punch and die may happen. So these are all the implications of not ensuring center of pressure while designing the blanking die. Now let us see how to calculate the center of pressure for the symmetrical shape blank. So here you can see it is a circle. It is symmetrical about both horizontal as well as vertical axis. If you want to calculate the center of pressure, for that, first we have to construct two reference axes. So one reference axis is X and another one is Y. And the center of pressure is located at the center of perimeter of this circular section. So this distance is R. Similarly, this height is also R from the reference x-axis. So here it is very easy to locate the center of pressure, which is R, R. Now let us see how to find out the center of pressure for a rectangular cross section. Here also the section is symmetrical about both horizontal as well as vertical axis. So if we draw the reference axis, here if we take that this distance is breadth, then this distance is going to be b by 2 from this reference y-axis, and this height is supposed to be d by 2 if the entire distance is d. So the center of pressure for this rectangular blank is b by 2 comma d by 2. So for this standard shape which are symmetrical, then we can easily locate the center of pressure. Okay, so now let us see some sections which are unsymmetrical but they are regular shape. So first let us see about the semicircular section. So here you can see it is symmetrical about the vertical axis, not about the horizontal axis. So this x bar we can easily locate. This is R, and this height, that is the center of pressure from this reference axis, that is this one is x and this one is y. So the center of pressure from this y reference axis is R, and from this x reference axis is 2r divided by pi. So the center of pressure is here, which is r comma 2r divided by pi. Otherwise we can write it like this: x bar is r, y bar is 2r by pi for this semicircular cross section. Now let us see how to find out the center of pressure for the quarter circle. So here, if I take this as a y reference, and this is x reference axis. So from this reference axis, the center of pressure is 2r divided by pi. Similarly, from this reference axis, it is 2r divided by pi. So it is here the center of pressure is, which is 2r over pi from the y, as well as 2r over pi from the x reference axis, or otherwise x bar is equal to 2r pi and y bar is also equal to 2r divided by pi. Okay, fine. Now let us discuss the standard procedure involved in finding center of pressure for an irregular shaped blank. Let us consider a simple example to understand the procedure. The first step is we have to divide the blank edges into number of standard elements. So as you can see, it is the given irregular shaped blank. Now we are going to divide the edges of the blank into number of standard elements. So the first element we consider here is the straight line, and the second one is the perimeter of this semicircle. So this arc length is considered as the second entity, and the third one is this slanting line, and the fourth one is this horizontal line. We have divided the edges of this irregular shaped blank into number of standard elements. The elements are 1, 2, 3, 4. The second step, we have to find out the length of each element. So the element 1 is a straight line, and element 2 is the arc length of the semicircle, that means the perimeter of this semicircle, and the third one is length of this slanting line, and fourth one is length of this straight line. Okay, it is horizontal. So after finding the length of each element, we are going to construct your reference axis. So here we consider two reference axes, x and y. We have to consider this reference axis in such a way that the boundaries of the irregular shaped blank lies within the reference axis. So after constructing the reference axis, we are going to find out the center of each standard elements from the reference axis. That means first we are going to calculate the center of this element 1 from x and y reference axis. That is why we call that as x1 and y1. Likewise, we have to calculate center of each standard element from these reference axis x and y. So after finding the center of each element, we are going to find out the center of pressure of the irregular shaped blank, that is x and y. So x is the center of pressure with respect to y axis. So how to find out this x? X is the summation of the product of length of each element and the center of each element with respect to y axis over the summation of the length of the irregular shaped blank. Okay, so like that we can calculate the center of pressure with respect to x axis, that is y, by finding the summation of the product of element length with the center of standard element with respect to x axis of each element over the summation of the length of the entire irregular shaped blank. So by following this standard procedure, we can calculate the center of pressure value of an irregular shaped blank. In my next lecture, I have explained this procedure with the help of your case study. So you can check out that video to get to know more about how to apply this procedure for a irregular shaped blank with a real life example. Thank you for watching.